just 4 other presenters to go. So for those of you, again, who want to see these other last 4 very exciting technologies, and we see other people coming in, so we're all good. You know, every day now, new distributed solar systems and EV charging stations are being deployed all over the world. But how is the grid going to know whether all those new behind-the-meter assets are consuming or returning power to the grid? Well, Kitu Systems has developed a unique communication protocol that meets California's soon-to-be law Rule 21, which requires that all smart inverters must be able to communicate their operating status. And Rick Kornfeld, their president and CEO, is going to tell you how this has led to commercial traction with several utilities and even OEM car manufacturers.
Thank you. Thanks very much. Boy, this is going to be hard to see from here. All right, well, let me just, yeah, well, I need my glasses for that, so, all right. So just a little bit about the problem and what we're doing. So I think as Marty mentioned, the penetration of some of these devices is really going up. Things like solar, battery storage, and very large loads like electric vehicle. And as good as these things are, they cause instabilities in the grid. And so what is needed is a way to monitor and coordinate the operation of all these devices. And to do that, you need a communication infrastructure. It's funny that people don't realize that in California, for example, we've had blackouts because we have too much solar. It's a little bit of a counterintuitive that too much generation causes a blackout, but it has happened here. Now, you can coordinate the operation of these, which doesn't really impact negatively any of the owners of these devices, and do so and allow for a very large increase in the penetration of these devices. The way to do this is through a communication infrastructure that's very, very flexible and can allow for the devices we know of today and the business use cases we have today and into the future. What we did in Kitu was we launched the development of a standard and a whole system that has now been adopted. It's an IEEE standard, and it is now mandated in California and being used outside of California, for example, in Hawaii, in some of the sunny states in the West and the Northeast, and even internationally, for example, in Australia. The regulatory environment is actually very good for us right now. It's not necessarily something you would build a company on. It's something more we view as winds at our back, but it's actually been very good. One of the things to keep in mind is that in January of next year, January 2020, it will be mandated that you have to have this technology for any device that has the capability of putting energy back into the grid. So we are, at this point, it's an open international standard, but we are, without any doubt, the leader in it. We have traction, and I'll talk about that in a second, with not only key utilities, but also key manufacturers in this space. We are in production. We have customers using our technology for mission-critical operation today. Okay? We are a San Diego company. We have about 37 people. There's also this convergence that's happening. People so often have viewed the coordination of generation and the coordination of demand response or of loads as separate things. They're not. They're not separate things, and what we're seeing is this convergence. I won't go into it a lot, but this convergence, especially when it comes to the either service providers or utilities that are trying to coordinate the operation of these devices. And again, this is a place where we are, I think, unique in that we're one of the, I think maybe the only company that views all of these different types of systems as one type of system that can be coordinated centrally. There are a number of utilities, and we talk about some of them here, that are actively working on this kind of converged coordination of these devices. I'll talk a little bit about just a couple things, just on it's some of the things that just indicate some of the traction. In California, there's now a requirement that's called telemetry, but it basically is monitoring of very, very large, now up to many megawatt systems, and this is all now mandating our technology and our standard. And you can see here on the right-hand side the different utilities. These are the different IOUs in California and their production plans for rolling this out, which looks like a long time, but in utility world, this is actually a very, very short period of time. And I mentioned the regulatory environment. This is called in California Rule 21. In Hawaii, it's called Rule 14. In other places around the country or the world, it's called something else. You can see here just some of the mandate for what's happening here. And the key thing is that this now is mandated starting in, as I mentioned before, in January of this year, of next year. And it's also interesting to note that in California, all new residential also has to have solar. So we're going to see this kind of technology coming to the market, which is to coordinate these devices and an increase in the number of these types of devices. Okay, a little bit about our system. This is just a very, very high-level diagram. On the far left is what's on-premise at the utility or within the service provider, and we work with both. It's very interesting if you think about, we are actually on-premise at utilities. That is not an easy thing to do, especially for a company of 37 people. Everything from the way our company is structured to our cybersecurity regime to the technology. We also have a analytics engine. It's up on the very far left called Compass, which is a graphical user interface, an analytics engine, which gives the utility sort of the situational awareness they need to see what's happening in the distribution grid. We have a service platform in the middle called Convoy, which is, again, for all these types of devices. That service platform is being used in production, as is the utility piece. And in the very, very far right, there's the technology that goes in the end devices themselves, which we call Spark. Just a high-level overview. Our Citadel, meaning our utility on-premise piece, has been deployed now in a number of utilities. You can see here, again, this is not easy to do for a small company. And we have a number that are coming. We are in the field. We have a number of production trials or production commercial deployments, as well as a number of field trials that are going on. We are working with a number of manufacturers. These are just to pick out some of the ones that are actually using our APIs, meaning they've integrated with our system, whether in the on-premise, the utility, or on the service side. Some interesting companies here as well. And that's it. So thank you very much.
All right, our last presenter in the smart grid and energy services category, as again, following up right on what Rick and Kitu are doing, there's all these new decentralized and digitized grid assets proliferating across the end user base and industrial control systems. But with each of those, we're introducing more and more cyber attack vectors to critical infrastructure. And Kay Katanatni, Cubatech's VP of Engineering, is going to tell you how Cubatech is going to present these cyber attacks for critical energy, 5G telecommunications, and defense applications.